part 3 of the chapter 1 lecture. This is going to be on measurements and units. As chemists, we have to make a lot of measurements in the laboratory. But once again, we run the risk of not having anything standardized if we don't have a system that we all use. Therefore, we have devised this metric system, we call it metric system, where we do measurements, and then the international system of unit is just a slight modification of the metric system, the original metric system. But in the metric system, it's a simple way to figure out units because they're all multiples of 10, and that's where the metric system is based on. It's based on multiples of 10. So every unit changes from the unit preceding it or that comes after, either by being divided by 10 or multiplied by 10. So in general, it's an easier way of keeping track of units than it is, let's say, in the English system where the divisions are not uniform. The measurements the main measurements will include units for length, mass, temperature, volume, and time. And there's another one, but we're not going to talk about that. That deals mostly with physics. But the length, mass, temperature, and volume we're going to use extensively. These are the measurements, the main units, the base or called basic units. And here is the units in metric and the international system or SI units. For volume, the metric unit is liters. In the SI unit is cubic meters. For length, we use meter for the metric and meter for the SI unit. For mass, we use the gram for metric and the kilogram for SI unit. Temperature is degrees Celsius for metric and Kelvin for SI unit. The time is in seconds for both. So let's look at these a little more in detail. We're not going to look at time, but these other basic units. The length is a measure of distance. So we measure it in units of meters for both the metric and the SI systems. Now, meter is quite a large unit. So it's about a yard, just a little larger. And so this is not very feasible for chemists in a laboratory. We use smaller units, such as centimeters, millimeters, and now we're moving to even smaller, micrometers or nanometers, especially for those who are working in the nanotechnology. They deal with nanometers, meaning 1 × 10 to the minus 9th meter. So if I take, for example, the unit, a meter stick, if I take it and divide it, so it's a meter long, if I divide it into 100 different parts, that would be a unit of centimeter. One of those will be a centimeter. So as you can see here, here's a centimeter, and 2 and 3 and 4. So this is a meter stick that's been divided into 100 parts, equal parts, and one of those is equal to a centimeter. If I take one of these centimeters and I divide it into 10 more parts, one of these is called a millimeter. So a meter will have 100 centimeters or 1,000 millimeters. That's all because they're divided into multiples of 10. The yardstick in the English system, however, it's about 3 feet. 3 feet is a little less than a full meter. And the foot is divided into 12 inches. An inch is a little larger than a centimeter. It's actually about 2.5 centimeters. So here's the conversion factors that you can use, whether they are in the metric system from meters to centimeters, or these three have to deal with conversions from the metric system to the English system, and vice versa. Let's look at mass. What is mass? It is a measure of how much stuff you have in an object. So the quantity that it contains. It's not the weight, because the weight is actually a force. It's multiplied by the acceleration due to gravity. Therefore, it's not a weight, it's just how much stuff you have in a particular object. The weight is going to be different depending on gravity. It's going to be different on Earth versus the moon, for example, or in Mars, because they have different gravity forces. The gravity on Earth is much larger than that of the moon, which means that in the moon we weigh less than we weigh on Earth. However, the mass of the object does not change whether you're on the moon or in Mars or on Earth. It doesn't matter. So the mass is just the quantity of material you have, not the weight of it. We can measure it on a balance. The SI unit for mass is the kilogram, but most often the chemists use grams in the laboratory or milligrams as well. So we use smaller units than the kilogram, which is pretty large. Some of these relationships that we're going to be using as conversion factors are listed here, whether it is looking at just the conversions between the metric system, or if we are looking at the metric system conversions to the English system. The ones that we're going to be using the most are right here. So I would just make sure that you remember these, memorize them, because we will be using them when we do conversions. Let's look at temperature. Temperature is a measure of how hot or cold an object feels. When we touch something, we know it's hot or cold because of its temperature. If it's hot, our hands will tell us that it's hotter, so its temperature is it's higher than our temperature of our hand. Or if it's cold, our hand temperature is larger than that particular object that we're touching. Now, we have three different scales that we're going to talk about. The Fahrenheit you're most familiar with. This is the English way of measuring the temperature. The metric system uses the Celsius scale, and the SI system uses the Kelvin scale. The Celsius and the Kelvin are based off the boiling point and the freezing point of water, and therefore they're both divided into the same amount of units. So for Celsius scale, we take the temperature of freezing of water and the boiling point of water, and that goes from 0 to 100 and is divided into 100 parts. And so every degree is 1. If I'm moving from one to the next, it's 1 degree. The same thing is true for Kelvin scale. Although instead of starting at 0, I start at 273 and I go to 373. And this is also divided into 100 kelvins, 100 parts. Each part has 1, is equal to 1, the same as with the Celsius. This isn't true for the Fahrenheit. The Fahrenheit has the freezing point of water at 32 and the boiling point of water at 212, meaning there are 180 little divisions from the boiling point of water to the freezing point of water. Therefore, this isn't as easy to relate to Celsius and Kelvin as it is between the Celsius and Kelvin scales. Now, we use the Kelvin scale for some parts of the chapters that we're going to talk about, and then use Celsius for others. So I'm going to tell you when to use Kelvin and when to use Celsius. But the Kelvin scale, the lowest possible temperature that we can achieve, also called absolute temperature, is 0 Kelvin. That is the temperature in which all of motion completely stops. We know that molecules are in motion even though we lower the temperature. There's still a little bit of motion vibration that occurs within molecules. But theoretically, at 0 Kelvin, all motion stops. We have gotten to a few hundredths of a degree of Kelvin, but we can never achieve complete and total um, ceasing of motion at 0 Kelvin. That is not quite possible. We've gotten close though, so that's interesting. But absolute temperature, know that absolute temperature is 0 Kelvin on the Kelvin scale, or minus 273 for the Celsius scale. These are the equations that we're going to use to convert from one temperature to the next. So let's say I want to convert to Fahrenheit when I have degrees Celsius. Let's say I have 10 for degrees Celsius. What I'm going to do is use this top equation to convert from Celsius to Fahrenheit. So 10 times 1.8 plus 32 versus when I have the temperature in Fahrenheit and I want to convert it to Celsius. These are the two equations that we use. Your book uses 5/9 for these, or 9/5, but I just find that it's easier to use 1.8. If you wanted to use 5/9 and 9/5, that's up to you, but this is how I learn it, and it's easier for me. If you find the other way easier, then use that. Practice a few of these. The worksheet has a few problems. Just practice a few so that you are familiar with how to convert. This is the hardest ones. These are easier for students. The Fahrenheit to Celsius and Celsius to Fahrenheit are a little harder to calculate. But then the Kelvin to Celsius or Celsius to Kelvin is only 273 difference. So if I'm converting from Celsius to Kelvin, all I have to do is add 273 to Celsius. To convert from from Kelvin to Celsius, all I have to do is subtract 273. So if I had 500 Kelvin, I wanted to convert it to Celsius, I would do 500 minus 273 to get to Celsius. So this is a little easier than Fahrenheit to Celsius and Celsius to Fahrenheit, but practice both just so that you are familiar with how to convert from one scale to the next. Volume. Volume is the three-dimensional space that is occupied by a substance that has mass. So if I have whatever object that I have, the three-dimensional shape of it is called its volume. It is measured in the SI system, it is measured in meters, cubic meters, or meters cubed. However, as chemists, we use liters or milliliters and even microliters. Liters is quite a large unit, so typically we will use milliliters a lot, and even microliters in smaller quantity as well. Here's the relationships that we are going to use to convert the top one from metric unit to another unit in the metric system, whereas the bottom two are units from the metric system to the English system. We measure these by using graduated cylinders, and we have all sorts of graduated cylinders from 1 liter all the way to 10 milliliter graduated cylinders that we're going to use. We're mostly going to use the 10 milliliter and 50 and 100 milliliter graduated cylinders, but there are larger than those. This is a very useful unit that you should know. 1 liter is equal to 1,000 milliliters. So memorize that because we're going to be using it when we do conversions. Let's talk about density. Density is a derived unit. Why do we call it a derived unit? Because it's not a base unit. It is calculated by knowing the mass of a substance and its volume. Therefore, density is given as mass of a substance divided by the volume of that particular substance. If a substance has a higher density, their particles are much closely packed together than those that have lower densities. And for the same unit of volume, let's say if I have 1 milliliter, for the same unit of volume, that substance whose particles are much closely packed together will have a larger mass and therefore will have a larger density. Those substances that have, for the same number, so for the same volume of 1 milliliter, their particles are quite farther apart, the mass is going to be smaller and therefore the density is going to be smaller as well. Typically, we measure the density of a solid or liquid in grams per centimeters cubed or grams per milliliter. 1 centimeter cubed is the same as 1 milliliter. For those of you going into nursing, you should know this. 1 centimeter cubed is 1 milliliter cubed. 1 meter cubed is 1 liter. However, we're going to be using both of these units to do calculations. When we talk about a gas, so these were for solids or liquids. However, when we talk about the density of a gas, typically we express that in grams per liter because their densities are so much smaller than a solid or a liquid. Therefore, these would be too large of a unit or too small of a unit, so we need to use these. A quick rule of thumb to figure out the density of certain substances is if we place them in water. For example, water we know has a density of about 1 gram per milliliter. If we place something in water and it sinks, those substances will have higher densities than 1 gram per milliliter. There it is. A piece of aluminum, for example, has 2.7 grams per milliliter as a density. That means it's not going to, it is denser than water, so it's going to fall through water. It's going to go to the bottom. Lead has a much higher density, 11.3 grams per milliliter, so obviously it's going to fall to the bottom. If something is floating, then we know that its density is going to be less than that of water. Let's look at ice, for example. Ice has a density of 0.92 grams per milliliter, where water has a density, liquid water, of 1 gram per milliliter. This is smaller, so therefore it floats. Look at cork. It's even smaller, so it floats. Now water is one of those weird substances. It's actually an exception because mostly the density of a solid is higher than the density of the liquid, but not for water. And this is a good thing for us because water freezes from the top instead of from the bottom. And that makes it possible for fish to survive in the winter when the water freezes in the lakes and the ponds. If water froze from the bottom up, then the fish would never survive. But because the water, as it freezes, the solid, it becomes solid, it floats on top of the water. And that's where you get that sheet of ice. You get it on the top and not at the bottom. Because ice, when it forms, it actually floats to the top. Its density is less than that of liquid water. Now I mentioned that we use the metric system, but we use several different units. And here's a table that shows us all of those units in the metric system. We use these prefixes that are attached to any units to tell us whether we're increasing or decreasing the size by a factor of 10. Right here in the middle, even though it's not shown, is our base unit. And then the deca, for example, which is abbreviated with a DA, it's 10 times that base unit. So if I have a decaliter, that means I have 10 liters. 1 decaliter has 10 liters. A hectoliter has 100 liters, etc., etc. So every time I increase, so here's a kiloliter, that's 1,000 liters. If I increase by my unit from my base unit, every time I increase in steps, I increase by a factor of 10. Or if I go in the opposite direction, I decrease it by a factor of 10. So I divide by 10 every time I go down. So a centiliter is 1/100th of a liter. A milliliter is 1/1000th of a liter, or 1 liter has 1,000 milliliters, etc., etc. Now we're not going to be using all of these units and the prefixes that are attached. These are the ones that I want you to remember. I want you to remember the kilo. I want you to remember the centi, the milli, and the micro. So these 4 units I want you to remember: the kilo, the centi, the milli, and the micro. So figure out how to actually go from the base unit to any of these units and do calculations and conversions with them. We will also work in class. We'll have to do some of these. But practice going from one unit to the other, from the base unit to other units, by either multiplying or by dividing by that particular factor. So here, for example, this is my meters. If I'm going from meters to centimeters, 1 meter has 100 centimeters, which means that if I have 5 meters, for example, I will have to multiply that by 100 to give me 500 centimeters. If you're going from a larger unit to a smaller unit, you will multiply by that factor, which means the number in front of the unit will get larger. We do the same thing in the English system. So if I'm going from inches to, well, let's say from feet to inches, feet is a larger unit than inches. So if I'm going from feet to inches, I multiply by 12. So if I have 2 feet, that makes it 24 inches, which means that the number 24, the number in front of my unit, which is inches, is larger than what I started out with the feet. That was 2. Therefore, going from a larger unit to a smaller unit, I multiply by the conversion factor. When I go from a smaller unit to a larger unit, I divide by the conversion factor, which makes the number in front of the unit smaller. I have these problems. The next 2 slides have these problems where we practice conversions, and I have actually specifically worked out videos on how to do these, and so you can watch those videos. You can try these on your own. You can also watch the videos and you can learn how to do them and see if you can get the same answer. So these are the 2 slides. These are more problems type, and these are just straight conversions. But you have these 2 slides that I've worked out videos on how to do these problems. And this will be the end of this section for the measurements and units, and then we will do another part of the lecture on dimensional analysis.